Kia ora guys, Mr. Migglesy hates being on camera, so there you go. Today we are going to have a look at the excellence task for the linear algebra practice assessment. So the task reads like this. Mr. Jahal has a drone that he wants to attach a camera to film the race. I think that's meant to be a 2 there. To film the race. He wants to plot a course that is 2 meters behind and parallel to whichever runner is in last place. Describe a path that the drone can drive being 2 meters behind and parallel to whichever runner is in last place. So first thing we're going to do, let's have a look at my graph and we'll see what that might mean on my 3 functions. So here we've got Mr. Hamilton, then we've got me, Mr. Forbes, then we've got Mr. Jahal. So what he's asking is he wants a drone to start behind the person in last place. So we're at like the time equals 0. So right at the start, the drone's going to be behind Mr. Hamilton by 2 meters. But then what happens is Mr. Hamilton actually passes me. So I start being in last place. So the drone's then going to need to follow my line in parallel. And then at the point where I pass Mr. Jahal, the drone then needs to follow Mr. Jahal 2 meters behind until the end of the race. So let's just go through this slowly. So first thing I want to do, who is in last place at different points in the race? So let's have a look. So Mr. Hamilton is in last place from here, right at the start, and he's in last place up until this point here. So what is this point here? So what you can do is you can actually find out that point by just clicking on this coordinate here. But I've already labeled them. So here it is, 23.9 and 19.5. So that is the point where there is a crossover. So let's just get this. So Mr. Hamilton is behind from where he starts at 0 and he is at negative 100 up until 23.9. So we could say Mr. Hamilton from t equals 0 until t equals, and here it is up there, 23.9. Right, so now let's have a look at next. So then what happens is at 23.9 I am in last place up until this point here when Mr. Forbes passes Mr. Jahal. So here it is here, and it's at t equals 47. So Mr. Forbes from t equals 23.9 until t equals, whoopsies, my memory's not good enough, I think it was 47. Yes, 47. Right, and then we know the last one's going to be Mr. Jahal from t equals 47 until the end of the race. So we've got to find out when he finishes. So Mr. Jahal finishes, here it is, here's the coordinate, at 370 seconds to t equals 370. Alright, so this is when different people are in last place at different points in the race. So this isn't really maths yet, and it's not really English yet. So what I'm going to do is I'm going to change it so that we've got an English written one over here on the left, and then we've got maths on the right. So in maths what we would write is we would use an equation to say this, and we'd say 0 less than t less than 23.9. So that means that t is between 0 and 23.9. So for this one, what I'm going to do is I'm going to do a little cheat. I'm going to grab that and paste it down there, and I'm just going to change out these things. So it's from 23.9 up until 47 is when the drone will be following me because I will be in last place. And then finally here from 47 until the end of the race, the drone will be following Mr. Jahal. So this is like how we write out domains. These are domains. So maybe I'll do that over here, These are domains. Whoopsies. Domains. Here. So it's between these values that the drone's following. Over here I'm going to write the proper like commentary. So from the start until 23.9 seconds. So I'm just going to change these from 0 seconds to 23. Ooh, I'm going to have to change these domains placements. Oopsies. go. Mr. Forbes from 23.9 seconds until 47 seconds. Fix that. Beautiful. Mr. Jahal from 47 seconds to 370. Remember, when you're doing this assessment, you need to communicate your answers, and that's the same for all mathematics in NCEA. So we've got the domains, which is like the maths version, and then we've got over here what you actually need to write for commentary. So maybe I'll write in here commentary. I don't know how to spell that. Maybe it's commentary. Oh, all right, Google's fixed it for me. All right. So these are going to be the points. So the next question is, how do we get the drone to be 2 meters behind each person at different points? So Mr. Hamilton's first, and his equation is d equals 5t minus 100. So how do we get the drone to be 2 meters behind? So all we need to do there is minus 2. But the thing is, what's negative 100 minus 2? That's negative 102. So I'm going to change this to following Mr. Hamilton, and that's the new formula for following him. Then we're going to make one for following Mr. Forbes. All we do is make that minus 42. And then we're going to make one for following Mr. Jahal, and that's going to be, what's 30 minus 2? Let's do that a little slower, eh? 30 minus 2 is 28. So I'm going to make that plus 28. So now we've got the drone's formula for following each person. So we've got formulas and we've got domains, or we've got the time set. So what I'm going to do is I'm going to join these together so they're on one screen. Right, who was in last place at different points, and what is the formula we need to follow. So this is actually all of the information that we need to get our drone ready to go. I'm just going to show you how to program that into Desmos. So between 0 and 23.9, it's going to be Mr. Hamilton, right? So I'm going to chuck that in there. It's from here to there. And from time is 23.9 seconds to 47 seconds. That's when it's following me, Mr. Forbes. So I'll chuck that in there. And then from then until the end of the race, when Mr. Jahal finishes, that is when the drone will be following him. By the way, my formula for Mr. Jahal's wrong because I didn't want to give you guys like the actual answers. Right? So this is all we need, and I'm just going to show you how you do that in Desmos. So we're going to join it all together now. So to join it all together, actually that's what we just did then. So I'm just going to get some space up here. So we want to now program this into Desmos. So we've got our formula here. So these are the lines that are going to be following at different domains. So that's the drone. So in Desmos, you get, if the time is between points A and B, then follow this line. So this is like coding. It's an if-then statement. So you write it out like this. You write y equals, or you could write d of x equals, and you write between these two times, follow this formula. And then you do a comma, and you write between these two times, follow this formula. Between these two times, follow that formula. So it's an if and then statement. So let's have a look at what else might look like. It might be the d of, oopsies, I'm going to do this. So actually let's just program it in here, eh? So now what's A going to be for my first time? Let's look here. So Mr. Hamilton is between 0 and 23.9, and we're going to follow, oopsies, I made this wrong, what was that meant to be? It's speed and time, so it's actually mt plus c. So we're going to follow Mr. Hamilton's equation, which is here. I'm just going to grab it actually, it might be even faster. So we want to follow Mr. Hamilton at the start, then we're going to follow Mr. Forbes, which I'm going to chuck into this one, and it's between these times. Oh, how convenient that it's all built up for us. And then I want to follow Mr. Jahal. Ooh, what did I do wrong? No, nothing. For the final segment of the race, and that is between 47 and 370. So that's how you write out your program. Just remember to include, pretty sure this is a semicolon or a colon, I don't know. Who knows? I don't know. I'm not a limit English teacher. This is a comma, I'm pretty sure, which is good. and these are parentheses. So you need to make sure you include parentheses, have these less than signs. You can use less than or equal to, it doesn't really matter, because at the point where they're intersection they actually equal both at the same time, so it doesn't matter. So between here and here, this is the formula we're going to follow. So what we're going to do now is I'm going to chuck that into Desmos. Let's see if I can get it to fit on the screen, and then I'll get Desmos up here. Nice. So we're just going to copy that into Desmos. So I'm going to make a new line, and I'm going to write y equals, let's pull this across, I open the parentheses like this, from 0 to 23.9. I want the drone to go at 5t minus 102, comma, from 23.9 up until 47, I want the drone to follow 2.49t minus 42. And finally, from 47 up until 370, I want the drone to follow this line, t plus 28. So now I've got my drone all set up. We can go away from our Google Doc for a second. So this is what it looks like in Desmos. I'm actually going to make my drone have a funky little path. So I'm going to go purple, and I'm going to do this type of line. So you see now what our drone is doing. So you can see it starts down here. Let's zoom in. It starts down here, and see how it's always just 2 meters behind Mr. Hamilton. And it goes up, it follows Mr. Hamilton, then it switches over to the red line. Now the gap looks like it's a different size, but actually the distance at a certain t value is always 2 meters. Right? So it follows Mr. Hamilton exactly 2 meters behind at every point. Then it follows me exactly 2 meters behind at every point, and then it switches over here to following Mr. Jahal 2 meters at every point, up until right at the end of the race. Whoopsies, got a bit more moving to do. It follows Mr. Jahal for ages, actually. Come on. Yep, and at this point here, the drone stops because the race is finished. So, let's have another look at the question again and see if we've answered the question in context, because that's really important. So he has a drone that he wants to attach a camera to film the race. He wants to plot a course that is 2 meters behind and parallel. You saw ours were all parallel to whichever runner is in last place. Perfect. Describe a path that the drone can drive being 2 meters behind and parallel to whichever runner is in last place. So here, we probably want to say Mr. Hamilton from here to here, right? So I've sort of described it mathematically, but when it comes to the actual assessment, you'd probably be better off to put it into commentary form. So I want the drone to follow Mr. Hamilton from 0 seconds up until 23.9 seconds on a path of 5t minus 102. Cool. I hope that helps, and I also hope it's not too long.